So we are going to start with our MapReduce now. I hope all of you have got done the Java prerequisites, especially our non-Java guys. If you haven't done it, please do it this week because we are going to start with our programming today. Java is required for this particular module. First part of our MapReduce framework. Then we will have a second part, and then we will go ahead with advanced MapReduce. Okay, perfect. So in this module, we will talk about what all are the use cases where MapReduce is used. What is the difference between traditional way of computing and how does MapReduce change the paradigm? Look at the Hadoop 2x MapReduce architecture and the components. Understand the flow of your MapReduce execution. Implement the basic concepts and run a MapReduce program. So if you recollect, I had told you to watch through Sanjay Gimavat's video about what is MapReduce. So similar to that, for an easy understanding of MapReduce, there is in YouTube something called as MapReduce with playing cards. So that will make it a little bit easy. I found it to be helpful for a couple of guys who are not clear with it. So I would just go ahead, I'll give you the link, MapReduce with playing cards. Okay, see here, this is about a 10-minute video which will talk about learn MapReduce with playing cards. And then about 7 years back, there was a fantastic article. There was about 5 sessions of a session on MapReduce. I'll give you both the links. Give me one sec. So please watch this link, copy link location, and let me send this across to you. This is MapReduce with playing cards. Send to all. I forgot this gentleman's name. He's a very popular fellow. So if you go down, save link, copy link location, he has got about 5 lectures. Okay. So see over here, you would see cluster computing 2, 3, 4, 5. Yeah, that is Aaron. Sorry, Aaron Kimball. So this is a gentleman who is with, this was in 2007, but then it is still relevant today. Okay, there are 5 videos what he had given on MapReduce. See here, you can look at all of those 5 videos, and this is as a part of Google Developer Network. 1 hour videos, absolutely fabulous. Okay, so you can have, you need to look at these videos over the weekend also so that you will understand it. This is about MapReduce. Okay. So please go through those 2 videos so that you'll understand it. And of course, my explanation should also be enough. Let's see. Okay. So if your concepts are all clear, we will go ahead with it. So let's start with MapReduce. Okay. So when we talk about MapReduce, the only way how we can get to the data that is there in HDFS primarily is through MapReduce. MapReduce is a programming framework through which you will analyze it. Okay, no problem, Nagendra, that's okay. So if you want to talk about MapReduce, you will have to go through the white paper. So I would say that if you go down to the MapReduce white paper that was published by Google John Dean in the year 2004, that is one of the best information what you will get. So my suggestion is to really look at this PDF, look at what they're talking about, and it is absolutely fabulous. That will give you a very good idea about how MapReduce works. Okay, so that's the whole idea about how it would work. Let me close this. And if you look at the slide, what do we do in the weather data? You can find out the maximum temperature recorded in a year. You can prove how global warming is really happening. So these are the things where analysis of information via MapReduce would be good. If you talk about the healthcare domain, the problem statement would be, how do I remove the personal health information? Because every equipment would have some or the other personal information. So for analysis, I would want to remove the personal information from the de-identify or remove the personal health information. So these are some of the areas where MapReduce is going to be used. So let's see in a traditional way. Okay, without MapReduce coming up, how are we doing it? You had huge amount of data. Okay, somebody had to split that data into small chunks. So you had to write a Java code who will split the data into small chunks. Okay, then you will have to look at every record and grep that record. Grep is a Linux command which is for selecting, and then you will have to match that record, and finally you will have to store all the matches into one common location. So this was pretty time consuming and it was very difficult. So what does the framework do is, framework will allow you to split the data into 128 MB chunks using the framework. Then within each chunk, you have got something called as input split. I hope you are clear on this, guys. Block split versus input split. You would have an input split. You will analyze each of the input splits, and all of these things are happening in parallel. You don't have to write a code. There is a framework called as MapReduce which will allow you to do all of these things, so that you will only have to write your map and your reduce logic. Okay? So you have got big amount of data. You will have to split the data into each individual record. You will have to grab the record. You will get the output from each individual record. Somebody will have to bring together all that records, and this will be happening parallelly on two machines, and then we'll have it. Okay? So this is how we were doing it in a traditional way. You have got big amount of data. You will split it, you will grep it, you will match it, and then you will go ahead and you will cat it. So you have to write everything on your own if the framework was not there. Okay, let's go to the next slide. So if you talk about the MapReduce framework, see over here, the MapReduce framework will help you in splitting the data. Okay, based on what? If I may ask, how you identify a record in MapReduce? Which class identifies a record in MapReduce? It should be a simple thing, input format. And then you will have a record reader which will convert it into a key value. It will go to the mapper. In the mapper you will do something. You will pick up whatever you want. So let's take the example of this file that we spoke about, the transaction file. So let's say you want the sum of sales in Florida. Okay, in the map, what all are the columns that you're interested in? What does the input format do? It'll give me one record for me. Okay, and then it'll go to the map function. In the map function, what should I do? Which are the columns I'm interested in? This has got 9 columns. There is a transaction ID, there is a date, there is a customer ID, there is an amount, there is a primary product, there is a secondary product, there is a city, there is a state, and there is cash or credit. Which all are the columns that am I interested in the map? You will have the state column and the amount column, right? So depending upon your analysis, you will pick up whatever you want from the state column and from the amount column. That's exactly what you're going to do in the map. So the key value can be a singular key value, scalar key value, or it can be a composite key value also. So supposing I want to have the sum of sales of jumping category in Florida. So I would need a composite thing, right? I need jumping, I need sum, and I need Florida. So you will have to have a use case, or you will have to write the logic for identifying what is the key and the value. So this is the way how you will think of an analysis. So in the map, you will go ahead and you will identify what you want. That will go to the reduce, and then it will throw out everything. So this is the MapReduce way. So now, why MapReduce? Okay, so remember we said about moving data to code and moving code to data, right? We have also covered the concept of rack awareness. Got it? So the biggest advantage of MapReduce is its ability to take processing to the data so that the data gets processed in parallel. Okay? So what are we trying to show over here is this particular block is processed by this particular map task. That's what we are trying to show over here. So you will have your processing that will go down to each individual node and it will try to analyze it. Okay. So you will send the code to the data. So that is how it happens in parallel, and that is the way how the whole thing would work, my dear friends. Okay. Perfect. So if you're trying to solve a problem with MapReduce, this is the way how it will be. So we are trying to talk about the healthcare world. So in the healthcare world, all of your details would be there in your relational data store. Okay. You would use Scoop so that you will take a database dump in a comma separated value file and push it into HDFS. What do you want to push it into HDFS? You can do some pre-processing also over here. That is what this matches means. If needed, you can do some pre-processing of data as to what you need to push into HDFS. Once the data is in HDFS, it will be split across multiple nodes. Then you will have a map function which will go down to each node where the blocks are. You will write a map logic. It will pick up whatever it wants from the functions. That will be written to somewhere, and then reduce will read from there. Reduce typically means aggregation. Where did the name map and reduce come from? It actually came from a programming language called as Lisp, L-I-S-P. Map and reduce are functional. No. Google actually created it, but then the MapReduce has come from the programming language called as Lisp, LISP, in which there is a map and a reduce function, and it is a type of a functional programming. In functional programming, you do not talk about the state. You will always talk about the behavior. Okay, so Lisp is a programming language from where it comes, and it's a type of functional programming. So after doing the reduce, the data will be stored back into HDFS. So what am I trying to say over here is the input data is going to be in HDFS and the output data will also be there in HDFS. Okay. So see over here, guys, this is what is the architecture. So the client will send across a request for accessing something. So see over here, this is the way how the whole process is going to work. So here you've got a client. I'm going to explain to you how the MapReduce process would work over here. You've got a client, you've got a name node, that's a master, you've got two data nodes. On the name node, you will have your resource manager. The two parts of the resource manager would be an applications manager and a capacity scheduler. On every node, you will have a container. There are two types of containers. There could be a map container, there could be a reduce container, and there could be an application master container. Okay. So let me give you an example over here so that this becomes clear for you. Let me remove this before I actually move on. Yes, even SAP has got it connected to Hadoop. So there we go. So what do we have? We have got a resource manager. Before even we look at the diagram, I want the concepts to be clear. The resource manager will be there on the master. You will have a node manager which will be there on every slave. The resource manager will have your applications manager who is responsible for starting the application master on a node for every job. Okay, plus it will have the capacity scheduler. Okay, then the node manager will be there on every slave. Every slave will also have a container. Container is nothing but a JVM where the map and reduce tasks would be executed, and it will also have a container which is a JVM where the application master would be running. Okay, and if this is clear, we can easily go ahead and understand the architecture. The architecture is very important for you to understand. So what is node manager? Hey, every slave will have a component for coordination called as node manager. It was called as task tracker in the earlier version. Okay. One JVM can contain a map or a reduce or a application master. It cannot contain everything. Okay. Application master is a component which takes care of the life cycle. Remember, what is the disadvantage of your Gen 1? You had to talk about the life cycle management. Job tracker was getting overloaded, so they broke it up into the resource management is taken care of by Yarn, and the life cycle management is taken care of by the application master. Got it? So let me minimize this. So see over here, the client would be talking to the resource manager because it is submitting a job. Okay. So the client will submit the job to the master because it needs to process it. If you still have a confusion, ask me, I'll help you. Then on the resource manager, who is the guy who will talk? So on the resource manager, there will be an application manager who will start the application master on any of the nodes. Okay, who will take care of life cycle for that particular application. Okay, that particular application master will start the map task on the node wherever the data is. Remember, the processing has to start from the node wherever the data is. The reduce task can be created on the same node, or it can be created on any other node also. Okay. Then for getting the resources, application master will communicate with the resource manager for getting the resources. The node manager will also be communicating with the resource manager for getting the resources. And for checking the status of the work, the client will communicate with the application master for getting the status of the work, because the application master is going to talk about the life cycle of a job, guys. Okay. So just to make it a little bit more clear for you, let's say I have got a 10 node cluster, and 5 node cluster should be enough. 1, 2, 3, 4, and 5. Okay, and I have got a file for 200 MB of data. So 200 MB means it will be broken down into 128 MB, and it will be broken down into 72 MB. That's correct, right? So tell me, where will the map task be running? On which all nodes will the map task be running? It will be 1 and 3. On which all nodes will the reduce task be running, friends? It could be anywhere. Why not 1 and 3? It could be on any node, friends. That's the beauty. Okay? Because map is a separate process. Think of it like level 1 support, and think of it like level 2 support. Okay? I'm just giving an example over here. So that's why I gave you the multi-node cluster, so that depending upon how many nodes are there, how many reduce things are there, reduce will be running, friend. Okay, Prakash? So guys, I hope you are clear on this diagram as to what the purpose is. Fantastic. Let's move on. So these are all the different components what we have in MapReduce. I have just explained that to you. It's better to put that into a document. So client is a person who submits a MapReduce job. Resource manager is a cluster level resource manager, long life, high quality hardware. Node manager is one per node which monitors the resources on the node. He will interact with the resource manager for getting the resources. The capacity scheduler will also come into picture at that time. The job history server only maintains information about the submitted MapReduce jobs after their application master terminates. Okay, yesterday we had to start with our job history server. Application master is one per application, short life, coordinates and manages the MapReduce jobs, negotiates with the resource manager to schedule their tasks, and the tasks are started by the node managers. Container are created by the name node when requested. Okay, and allocates resources on every slave. Okay. Good, guys. So this is about the concepts. We are clear on this. So now you will actually be running a MapReduce application on Yarn. I'll be showing you how to do that. So everything is done by the resource availability on that particular node. So when we talk about a MapReduce job, there is a job submission. Remember yesterday we did Hadoop jar, the name of the jar, that's a job submission. There would be a job initializing that would happen. The individual task would be assigned on every node. The memory would be assigned. There would be a status update, that was communication call with application master, and there would be a failure recovery that will happen. If one of the nodes wherever the map runs fails, it will automatically be started on another node wherever the data is. Okay? Cool. So here we are going to talk about the execution of a MapReduce flow. One, you have got a client JVM. Client is somebody who's outside the cluster. He would submit a job. So that is point number one. How does he submit a job? He will say Hadoop jar, the name of the jar file, and he would press enter. That is the way how a job is submitted. When the job is submitted, it would go down to the management node or the master node, that is the resource manager, to get the new application ID. Remember, the job ID comes in. Okay. As a part of step number 3, he would copy the job resources. Remember, we said moving the code to the data. The code has to go to the data, right? So it will copy the job resources to HDFS in step number 3, and then it will submit the code to the resource manager. So these are the first 4 steps. There are totally 12 steps. So guys, I hope you are clear on the first 4 steps. Whenever you say Hadoop jar, the name of the jar file, the name of the application, and press enter, a job gets executed, which will go down to the management node for the job ID. The job gets copied down to the HDFS, because only HDFS will know which nodes have the data, and then the job gets submitted to the resource manager. Okay? Let's get down to the next slide. So now, step number 5, the resource manager will ensure that you start the application master container. Okay, so it will tell the node manager to create the container on the data node itself. So that is step number 5. It will start the application manager container by telling the node manager to create the container. Okay, so once that is done, okay, step number 6, it will tell the node manager to, okay, that, the arrow should have been the other way around. Okay, I think the create container arrow is what is this, node manager telling to create the container. And then step number 7, the application master will talk to the HDFS and will know the input splits wherever the data is, right? And it will tell the node manager to actually start the container for the map and the reduce. So that is taken care of by the app master. So that is what is the start container arrow that is showing. Plus, for any resources, he will have to talk to the resource manager for getting the data. And then you will see the node manager will actually start the container. That is step number 10. But before step number 10, step number 9 is the container would be started by the node manager. It will create that container on step number 10. The MapReduce task will actually go ahead and get the resources from the HDFS, and the execution would happen. These are the 12 steps that we have over here. What is submit application? Submit application is the command that you wrote, Hadoop jar, the name of the jar file. Okay, so all of these things happen when you run that particular command. So submit application means move that particular code or register that application to the resource manager. First, you say that you want to run a job. You will get the application ID, you copy the resources, you submit the application to the resource manager. Those are the first 4 steps. Okay, good. Velan said there are 2 start containers. Are they different? They are the same? No, they are different. The first start container is for the node manager to start the application master container, who is going to talk about the life cycle. And the second start container, create container, is for the node manager to start the actual container where the map and the reduce are going to start. So let me go up a little bit. I'll show you one slide before we had seen this. See over here, friends. There are three containers here, right? So there's a container for the application master. Then there is a container for the map and the reduce task, right? So the node manager will create the container for the application master, and the application master will tell the node manager to actually start the container for the map and the reduce. So those are the two separate steps that we have, friends. Let me go down to the actual slide now so that this becomes clear for you. Step number this thing is 6 is node manager starting the container. That is application master. Okay, so think of this arrow that you see over here, friends. Okay, this arrow that you see, what is highlighted, that goes from the application master to the node manager. It should actually be the other way around. Okay, and then the application master will, in the step number 7, will get the input splits. He will ask the resource manager in step number 8, and step number 9, he will tell the node manager to start the container, and the node manager will start the container. That is step number 10. The 11th, the MapReduce task will get the resources from HDFS, and the actual execution happens in the container. This is the complete end-to-end flow, guys. Okay, the client requests a job. Step number 1, I'm repeating the whole thing once again. It will talk to the name node for getting the job ID. The job ID will come back to the client. Client in step number 3 will copy the XML file and the jar file to HDFS. Then it will submit that application, whatever is needed, to the resource manager, so that there will be a queue. So remember, only when you submit application will the capacity scheduler comes in over here, right? Then step number 5, the resource manager will tell, okay, I have to start with the application master for that job. So it will tell the node manager to create the application master on one of the nodes. Step number 7, the application master will get the input split from the HDFS. Okay, then he would know which all nodes the data is. It will tell the node manager on that machine, okay, to start with the container. So that is what is step number 9. It will also talk to the resource manager in step number 8 to get the resources. The node manager on different machines will start the map and the reduce task. That is step number 10. Each task will talk to HDFS to get the job resources, step number 11, and finally the map and the reduce gets executed. So remember, the application master is one container, separate JVM, and the map and the reduce is another JVM. So there are three slides, right? Let me go up. See, the first slide is basically the blue arrow. The second slide is basically the orange one, and the third slide is basically the red one. Okay, that's all. That's the reason why we did it. Good. So that was about our complete end-to-end execution. So if you look at the screen over here, you have got the resource manager. There are two parts, right? I told you, applications manager and scheduler. The resource manager would, for the first job, create a container for the application master. Application master will tell the node manager on node this, I don't know what, let's call it a 6. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 top down. So the application master on node 3 will tell the node manager on node 4 to start with the container, and also the container for in node number 5, because that's where the map task or the reduce task will be happening. Similarly, for the second job, it is there on my application master is on my node number 6, 8, and it will tell on node number 4, node number 10, and node number 12 to start with the containers. So this is the complete summary of the execution steps. Okay. So sequences: client submits an application to the resource manager. Okay. Then the resource manager allocates a container to start the application master. Clear, guys? Okay. Then the application master registers with the resource manager because he will have to talk to the resource manager for the resources. Okay. Then the application master asks containers from the resource manager. Why? Because I know where the data is going to be, right? Then it will tell the node manager to launch the containers. Okay. Then the application code is executed in a container. Okay, then comes the status part of it. Client contacts the application master to monitor the application status. Guys, I hope this makes it very clear, guys. So this is the summary of your complete MapReduce workflow. And then once it's done, application master unregisters with the resource manager because I have finished with the job. Here comes Annie. So what's the answer for this, friends? Yarn was developed to overcome the following disadvantage of the MapReduce framework. I'm talking about the MapReduce framework. Okay, I'm not talking about the HDFS part of it. So single point of failure of the name node, that is HDFS part of it. Only one version can be run in a classic MapReduce. That's also correct in one way because you will only be running only MapReduce. But then the primary reason is the job tracker overburden. Okay, so the answer is C, too much load on the job tracker. Who removes that load? Application master. Okay, the right answer to the earlier question is too much burden on the job tracker. The next question, in Yarn, the functionality of the job tracker has been replaced by which of the following Yarn? So has been replaced by which of the Yarn features? So what are the two things where a job tracker had a difficulty? Okay, so the job tracker was taking care of the life cycle of your job. Okay, plus it was taking care of the resource management part of it, right? These are the two things what a job tracker was doing. So this is more of a checkbox. There are two things. Okay, so the functionality of the job tracker has been done by two phases over here. It is basically the life cycle. Life cycle means what? Life cycle means the monitoring of the task, right? Not the scheduling of the job. So one is resource management, that's for sure, most of you are correct. Resource management is correct. And the second one is your task monitoring. The job scheduling is taken care of by the framework, the capacity scheduler. Or there is also a scheduler called as FIFO scheduler. So it is actually two things, that is life cycle and the resource management. So see over here, this is what Annie had to say. So task monitoring, the fundamental idea of Yarn was to split up the two functionalities of the job tracker, resource management and monitoring ideally, okay, into separate domains, and that's why this answer, okay. The task tracker is on the data node like a node manager which will actually execute the task in which there is a JVM. True, VLAN, but ideally the scheduling is by another component. In your earlier world, the scheduling was also, although they said /scheduling, that is not the right answer, friend. The scheduling is actually done by the FIFO scheduler. Look over here, we have got a capacity scheduler and we have got an application master, right, friend? So there was also a scheduler in your Gento. Okay, I had given this comment to them earlier also that they should remove the word job scheduling. Okay, so the job scheduling is actually taken care of by the scheduler. So in Yarn, which of the daemons takes care of the container and the resource utilization by the applications? Look at the word applications. Focus on the word applications over here so that your concepts will be clear. Who will take care of the container, that is your map and the reduce container, and the resource utilizations by the applications? So this should be very clear. It is actually the application master. Okay, perfect. Can we run MapReduce jobs in a Yarn enabled cluster? Yes or no? So there could be two questions. Can we run a MapReduce 1 as it is in a cluster? But that's not what I had asked here. I had asked, can we run? So the answer is yes, of course. But if the question would have been, can we run MapReduce job as it is in the Gen 2? It would be no, because you will have to recompile it. So the important point over here is, yes, you can of course run MapReduce Gen 1, but then, hey, what does it? These can be run on Gen without recompilation? Hey, when I say recompilation, the jar files needs to be done. It needs the jar files. You don't have to recompile, but then since the library files are different, although there is a binary compatibility, the jar files needs to be done. Changed. Okay, because Gen 1 jar files are different, Gen 2 jar files are different. There we go. So which of the yarn or MapReduce 2 daemons are responsible for launching the task? What is actually the meaning of a task over here, guys? The map and the reduce containers. Okay, that is what is the meaning of a task over here. So who is responsible for launching the task, my dear friend? Good. Most of you have got it correct. Okay. Hey, launching the task, Koteshwara. Who is responsible for launching the map and the reduce task? He will talk to the resource manager, but then who will say that you have to actually launch it? Okay. So responsible for launching the task, not responsible for telling which task to launch. Okay, so the actual answer to this thing is the application master. So let's look at the complete life cycle. So now let's understand what is the complete flow. So there are 6 columns over here. The first is input. When I say input, I am referring to a block over here. Okay, so a file can have multiple blocks. Okay, and these things are going to be taken care of at every block level. So imagine my 200 MB file. I will have 128 MB and I will have 72 MB, right? So there are 2 input blocks that I'm having. The first phase is called as the splitting phase. Splitting phase means identifying a record. Okay, so splitting is looking at a block and converting that into records. Splitting is going to be taken care of by the input format, and after a record is identified, it is a record reader class which will convert that into a key value pair. Okay, so first is splitting, and then the record reader will convert that into a key value pair. Okay, what is the default splitting logic? /n or a new line. Okay, so now you will have, as a result of the splitting, you will have K1 and V1. Please note K1 is always the offset point. Okay, K1 is the cursor position in the file, which will always start from 0. Okay, good. So at mapping is a data stored somewhere. Remember, Velan, we had said earlier, the output of the mapper is stored and the node, and it is temporary till the time the job runs. After that, the job is, that data is ignored. Okay. How many maps and reducers? Let me copy that link and then we will have a look at it to see what are they talking about over here. There we go. Let me click on this wiki.apache. Let me click on enter again. I'm sure the slide is there. Okay. So see over here, number of maps. The number of maps is decided by the number of DFS blocks. We are talking about the map task. He is correct. Okay. But then what are we talking about over here? Within a map task, okay, within one block you'll have multiple records, right? Within one block you'll have multiple records. So one task will have to go through all the records inside that file, right? Exactly. So within a task, all the records are handled by the mapper sequentially. That's what happens, right? But then the beauty is parallelism. You can have multi-threading and all of that. So now each of the record will have to go through the mapper. So see here, each record has gone through the mapper and you will have your output of the mapper. So once the mapper has finished, Then comes the shuffling logic. The shuffling logic is controlled by the application master. Okay. So what does the shuffling logic do is it will look at the key across all the nodes, okay, and it will give those keys to each of the reducer, and so the output of the shuffling will be that you will get a key. Look at this, beer is there in the first output and beer is there in the third output, but after shuffling all the values for the beers will come together. Okay, so that is what is taken care of by the application master. The shuffling process ensures that all the values of the similar key that is executed in multiple nodes are all brought together, like how you shuffle a card. Shuffling will ensure that all the values of the similar key are brought together and given to one reducer, and then the reducer will do the aggregation of it, and the output is going to be written in the HDFS. This is the whole thing. Okay. So shuffling will ensure that all the values across the nodes are brought together. Shuffling is controlled by the application master, and it is actually all the values are taken from the individual nodes and it is given to a reducer. So it is happening on the data nodes. Remember, map task will run only on one node wherever it is. And when I asked where will reduce run, you said it can run on any node, right? So that is what would happen. So each of the reducer tasks will be assigned one of the keys and they will do the reducing, and the output is stored into the final result. Okay. So this is the complete end-to-end process of a MapReduce, folks. So let's proceed ahead, guys. So let me go down to the next slide. There we go. So if you look at the anatomy of a MapReduce program, everything is going to be a key value. The key and the value in the map would be the offset point is the key and the record is the value. It will get converted into a list of K2 and V2 based on the business logic, whatever you have in the mapper. The shuffler will ensure that all the values for the same key are brought together. So the input to the reduce would be a key and a list of values, and the reduce will do the aggregation. That is what is the anatomy of a MapReduce program that we have seen. I hope all of you have worked with listen to the video. Okay, today we are going to see how it works. So now, hey, there comes Annie. So what's the answer to this one, friends? Input to the mapper is in the form of what? Look at all the values. I'm talking about a mapper. How can it be all of the above, friends? So there are 4 answers, and there is proper representation for each of those things. So some people are saying B, A, B, C, D. First of all, how can input to a mapper be a flat file? Because input to a job is a flat file, not input to a mapper. So that is out of the window. Second, how can input only be a string? Because I told you some time back, look at the slide over here. The answer is over here, friend. Input to a map is going to be a key value pair, the offset position and the actual value. Okay, so the right answer is going to be B. So like I said, it's not C. So if it is not C, of course it can't be D. The right answer is going to be a key value pair. Please note, guys, the mapper accepts key value pair as input. So now we are going to see a demo of the word count very quickly. Okay, and we will see as a part of the assignment how to set up the Eclipse ID on your system. Then download all of the MapReduce codes and import them into the Eclipse ID. So you can either have an Eclipse IDE at your own Windows environment, or you can use your Eclipse that is there inside the VM. Both the options are okay. Then you will write a MapReduce code for the word count, and you will run the word count program on your cluster. So let me go ahead and quickly give you a demo of how to run it from Windows. So I already have got my Eclipse installed. Okay, in my Windows, I'm starting with my Eclipse over here. Okay, so while the time Eclipse comes in, let me go ahead. I'm having a version called as Juno. Okay, so you can go ahead and do this. The only challenge what we would have is the code that is there is what we have in our VM is 1.7. Whereas I have got 1.6. I'm just going to show you in case if you're doing it, the environment Eclipse is Eclipse. It will still remain the same. Okay, so you will open up your VM and then you will write the code. What I am going to show you as a part of the demo for the purpose of simplicity for the others would be, let me open up the VM, the Eclipse. So Velan said, we also see a sample of how to get the input data during development. Fantastic, Velan. Okay, so let me quickly explain the code and the process for you. So you have got Eclipse over here. Please start with your Eclipse. You see that we have got Eclipse Helios. Don't worry about that. And in the folder called as LMS, if you double click on that particular folder, that is your LMS. Let me scroll up. You will have a folder called as MapReduce. And if you look at the MapReduce folder, you will have a assignment data set for word count. You will have all the jar files that is needed over here. Double click on the jar file. So this is what is the actual jar of your program. Okay. So if you look at this module 4 assignment data set for word count, this is the word count problem data set what you're having. I'm just opening up the folders for you guys. So let me open up this particular folder also. Okay. So this is what is the input data that we are having, which I'm going to do a word count on. Okay. So let me close this. And my data is over here. Now let me look at my problem for my this is the data set. I'm just looking at where is my word count. This is the, I think this is also the data set. Okay, no, I'm not interested in the data set. I'm looking at my word count solution. Let me quickly look at my source and see if I have got my word count solution over here. No, these are all the other ones. Okay, doesn't matter, guys. So I know how to go ahead. I have got a sample example, so don't worry about it. So what are we doing? Let me go back and check if my Eclipse is running. I know where my sample data set is. Let me close my too many windows over here. So for the first time, it'll ask me, where do you want the workspace to be? So I want the workspace to be there at the default location, and I will say okay. So this is already done. Good job. Let me go back to my LMS, and in my MapReduce solution 3. Okay, let me go down to this particular folder, SRC in Edureka MapReduce. I have got my wordcount.java. This is the file I was looking out for, guys. Okay. So let me just double click on this particular file so that it will open up for me. Fantastic. This is what I wanted using gedit. Let me minimize this and let me close all of the other browsers. Too many windows. That's what I don't like. Hey guys, in CentOS, do any one of you know, whenever I click it, I don't want separate windows to open. I want it to open up in the same window. Let me maximize my Eclipse. This is what is Eclipse, what you're seeing. For the first time, you will see welcome to Eclipse window coming, and on the top, you can close this welcome so that it'll open up with the window like how you have. By default, they have created a folder called as HBase, which has got a source and which has got some default packages, etc. Don't worry about this. We are going to create a new folder. Okay, friends? Okay, guys, I hope we are all on the same page, right? I just want to ensure that the non-Java guys have actually done this. Getting it, friends? Cool. So the first step is you have to create a Java code. So I'm going to say file, new. I'm going to say project. And the project I'm going to use is a Java project. And what am I going to do over here is, hey, why are they using 1.6 and 1.7? because if I'm not mistaken, we have got 1.7, because if you use 1.6, then you would have a major dot minor version error, because JDK compatibility is should be there. Okay, hey, the folder will not be created. Only when you create a new Java project will it come. So please hold on, guys. Don't try to follow it at the same time. So I'm creating a new Java project. Okay, I know that the JRE is 1.7. So earlier it was by default 1.6. So I have moved it to Java SE 1.7, and I'm going to create a project called as word count. Okay, that is what is going to be the project name. Let me scroll down a little bit, and I would say next. So it will go ahead and create that project for me, and I will just say finish. So it comes up with a pop-up window and saying this kind of project is associated with a Java perspective. Do you want to open it up? Perspective is the different versions that you have. You can run a J2EE. You can use a Java. There are various kind of applications that you can use over here. So on the over here, wherever my window is being highlighted, you can see something called as open perspective. When you click on the other, these are the different perspectives that we have. Okay, so Eclipse is an IDE, integrated development environment, for working with the different Java-based components. I would say okay, and oops, sorry, by mistake I had clicked on C++ and said okay. I should have said cancel. Not a problem. So I'm there in the Java perspective right now, don't worry. Okay, cool. So now on the right hand side you see something called as a task list. You can close that. You don't need that. There's an outline thing that you will again see. You can close that too. So this looks compact. Now the first step in any development would be creating a package. So I will expand my word count folder. Okay, so Arun, are you seeing this now? So Arun had mentioned earlier that he can't see the folder getting created. Now you should be able to see the folder getting created. So you had mentioned earlier that the new folder is not created. I hope that is done now. Okay, fantastic. So take your time, look at what is happening. This will be there in the recording so that you will know very clearly how the whole thing has to be done, guys. Okay, fantastic. So now what am I going to do over here is I'm going to create a new package. In the word count, I'm going to say, just give me one sec. So I will say right click on the SRC, new, and then I will go down to package. I'm going to create a package called as in.edureka. Okay, so depending upon what is your way how you look at it, the packages would be created. Okay, cool. So then I would say finish. So a package is created. In the package I need a class. So let me go ahead and have a look at the class. The class is called as word count. So first let me create the class. So I will, on the in.edureka package, I'm going to say right click and say new class, and hey, let me call it word count example, because the folder is also called as word count and the Java file also word count. Too many word counts over here. So I am just going to say word WC example. Word count example is a name of my Java file. Okay, and I will just say finish. I created a new class. A class is a encapsulation for your code that you will be writing. So you would see this over here. It is creating a new class for you. So the class is created. Now what am I going to do is I'm going to simply go ahead and copy paste the code, and of course I will explain everything. Don't worry, guys. I'm going to explain everything. But before I copy paste the code, I would need to know the jar files that is needed in the program. Okay, what are jar files? These are all the jar files, that is dependent jar file that is needed for working with any code. Okay, we were saying where are they copying the code from? The code is being copied from the folder called as in the LMS. In your desktop there is a LMS folder. Go down to MapReduce and there is a folder in the MapReduce called as MapReduce Solutions Module 3. You would see these are the different folders what you have inside the MapReduce, and I'm copying it from the assignment solution module 3. I would recommend you to type the code Okay, for understanding, for ensuring if it works, you can go ahead and do that, but then you'll have to actually go ahead and type the code so that you'll understand what each of the things are about. So now what I need is I need to go ahead and need the jar files. So it'll be there in user lib Hadoop. So what am I going to do here is I will select the project, that is my word count. Okay, and then I will right click on that and I will select my build path, and then I will go down to configure build path. I need it from the original source where the softwares are. I will go down to the libraries on the top. So all that you have is your JRE library. I would say add external jars. So now I know that it is there in USR lib Hadoop. So let me go down to the file system. Let me go down to USR. Let me go down to lib. It's taking some time to open up the lib folder because there are too many jar files that will be over there. And if I look at Hadoop, see there is something called as Hadoop-2.2.0. Open up that Hadoop 2.2.0. Okay, and if you look at your lib over there, sorry, let me go back to the Hadoop. Just one sec. They have changed the location. Just give me one sec, friends. Let me go back to my software. I need to find out where they had. Okay, it is there in a share. Okay, it will be there in ETC. Yeah, it should be there in. Okay, thanks, Min, and thanks. Who was our other friend who was helping me? Ravindra. So let me go back to my ETC. Where is my VM? Okay, let me go down to my ETC, Hadoop. No, there are no jar files over here. Let me just go back. Just give me one sec, guys. I know. Let me go down to my Windows. Go down and see where my jar file is. Because in your Gen 1, it was there in the lib folder, so they have repackaged it. Let me go down to my software over here and Hadoop 2.2.0. Okay, go down to your share, Hadoop, MapReduce. Yeah, it is in share Hadoop MapReduce. Okay, if you look at the lib, all the library files are there and it is all available over here. Okay, it's in share Hadoop. Let me do that. It's in share Hadoop MapReduce. Let me go back to the VM. Let me go to Hadoop. Let me go down to share Hadoop. So typically the share is where you have got your doc also. Okay, so share Hadoop MapReduce, and you would have your MapReduce jar files. Or somebody was saying, Nagendra, all the jar file, I think we have kept it together in one location where it will be easy for you. Okay, can you let me know where it is? Let me go ahead and select these jar files. Okay, and let me scroll down and I'll say okay. Let me go ahead and say add external jars. I would need the jar files in your common. Okay, so from your MapReduce, I'm selecting all the jar files. Of course, only some relevant jar files are required, but I'm selecting all the jar files. Then I am going to select it from, okay, the Hadoop common lib would have all the jar files. You don't need this jar files. So I'll explain it. Don't worry, guys. Okay. Let me just go ahead and create all this, select all these jar files. This is what is the jar files, what we have in our, this one, what I call Gen 1. Just give me one sec. I'll give you the list of locations. Don't worry about it. Okay, you need your HDFS jar files. Okay. Just give me a couple of seconds. They're trying to make it as separate files. That's okay. Okay, some of them are common. I'll explain it to you. I'm just looking at the various folders. So in Hadoop, in MapReduce, lib will have some of the, okay, got it. So let me put it in the notepad. I think we are very clear. So we will write the code. So the jar files, hey, these are the resultant jar files. Velan was asking in the LMS jars, these are the resultant jar files. The jar files for your word count example would be there in, I forgot the path. It was in user lib Hadoop share Hadoop US user lib Hadoop -2.2.0 share Hadoop. Then I need to pick all the jars from the lib directory of your MapReduce, HDFS, and common. Okay, that's what, in case if somebody doesn't give it to you, this is the way how you should be able to do it. Okay, hey Nagendra, that is okay. For a Java developer, you can do it in a different way. Okay, cool. Let me minimize it and let me go down to the VM player. So I have done that, guys. So I have selected all the necessary jar files and I would say okay, and finally I would say okay. So all the jar files is setting, see here it is saying setting the build path, and on the left hand side you would see reference libraries which would have all the jar files. Okay, good. So let me minimize this. So I would need the jar files from 3 locations, from MapReduce, Hadoop, and common. Okay, although some of the files are repeated inside each one of them, it's better to add it. So now I've got a package and I've got a word count example. You remember that there are 3 things that we have to write. One, you will have to specify your mapper logic. There will be a reducer logic, and there would be a driver code. That is the entry point how the program would be executed. Okay. So what am I going to do is, let me go ahead and start with the first one. Let me go ahead and copy all these imports. What is import is, whenever you run any program, you would need some of these jar files. Okay, so let me not import it, and I will show you what would happen if you don't import it. Okay, so let me go ahead and write only my mapper code. So inside my class, I'm just going to select my mapper code. I'm going to do Control C and go down to my code and say Control V. Okay, and let me explain what this is all about. Okay, friends. So for the first time when I do this, you see here that it gives a lot of errors. Take your mouse on top of the mapper and it will tell you what should I import. Typically the first one is the closest one. It says import mapper from org.apache.hadoop.mapreduce. So we are telling it to import from MapReduce. Let me click on the first one, and then you will see automatically the import statement coming on the top, and the error of the mapper should go away. Just give me 1 sec. I thought I have done that. Okay, it's taking a little bit of time. Let me do that. Just give me 1 sec. I have clicked on that import. Come on. Okay, there we go. So saw how that import statement came on the top and the mapper went away? Now understood, Viv, there are, although this is only a small word count, but then the framework stuff for that is the same. A template is being created. Let me similarly go to long writable and let me do an import. Let me go down to text and do a import. Please be careful. I'm interested in org.hadoop, apache.hadoop.io. I'm not interested in the first one. Okay, text class is there in so many packages. I'm interested in the Hadoop one. Okay, then int writable. Please remember org.apache.hadoop is the package that you are interested in. Okay, let me click on this. Then IO exception, that is java.io. Okay, this is the Java code, friends. And then I'm going to use a string tokenizer, which will be there in util. Okay, there we go. It's in java.util. Let me click on this. And I'm very happy. My code is all clean. Okay, so let me explain what are we doing over here, friends. Whenever you write a MapReduce code, there are a couple of ways of doing it. One, you can write it in a 3 separate classes. Okay, the mapper code, the reducer code, and the code that is for execution, that is your driver code. Or you can create one class and you will have 2 inner classes inside that, and you will write the driver code in public static main. Okay, so we have done this. So what are we doing? I am following the second approach. So I say public static class map. So you can write whatever is the name of the class. Every mapper class has to extend a class called as mapper. Okay, that mapper class will contain the business logic, and whatever you see in the angle brackets are called as generics. Generics will ensure that you will get a compile time safety, and what is going to go inside that is a key and a value. Now let's say that you don't know what this is. The best way to look at is, I'm going to go down to my Windows, the place where I have got my Hadoop extracted. Okay, there should be a doc, because earlier it was there in normal docs. So let me go ahead and see where is this docs, because I really don't like the way how they have packaged it. Okay, in any program, Java developers will definitely know that doc will be there. Docs will be there at the root, right? Okay, so but here it is not there at the root. So we were saying, you are writing this code in the VM. Suppose if we write the code in our local PC, how do we copy the jar files in the VM to the local PC? So in case if you are using it in your local machine, you will have to download Hadoop. So in case if you are writing it code in your Eclipse, you will have to download Hadoop and keep it the same version, Hadoop 2.2.0. So how are you going to download Hadoop? You will go down to, give me one sec. I'll go down to the browser and I will search for Hadoop download. And in the Hadoop releases page, my this thing is acting funny. Okay, I'll go down to my download. Okay, and then I will click on download a release now. It'll automatically take me to a page where the download will be there. Okay, there you see Apache downloads. Go down to the mirror that it has given it for you, and in that particular mirror you would see oh, come on, you have got only 2.5.6, so we need a place where you will have 2.2.6. Just give me one sec, friends. 2.2.0, because that is the place where you will have. Let me go down to my 2.5.6. I don't know why they go down and look at that. Give me one sec. I want to Hadoop 2.2.0 download. Okay, there it is. This is there in the archive.apache. Just give me one sec. I just want to ensure that we are there on the right page. I'll give that link to you. Okay, there we go. This is what we wanted. I'm going to copy this. So you will have to download this file, the tar.gz file, 104 MB file. This is what you will have to do with, in case if you are doing it separately. I have shared that link. Yep, you're welcome. So let me just check if the docs are available over here. Just give me one sec. So Nagendra has given a link of the docs, but I think the docs should be there in the setup itself. Once you download it, Yeah, there we go. So it is there in your, wherever you have downloaded your Hadoop. Inside that, your share, doc, and Hadoop, you will have your API. So see over here, inside that there will be API, and in the API, double click on index.html, and I'm sure this will bring a lot of smiles on the faces of a lot of Java developers, because this is what they eat and breathe, the documentation. Okay, so in the document, and even for non-Java guys, this is very good. So if you scroll down to a package called as org.apache.hadoop.MapReduce, okay, in that, if you look at the mapper class, see, this is the mapper class. I'm selecting the mapper class, and on the right hand side it will explain to you what all are the parameters of your angle brackets, whatever you had, that's called as generics. Key in, key out, value out. Look at the explanation. It explains it in a very, very good way. See over here, maps input key values to a set of intermediate key value pairs. Okay, friends? So clear on this? So now let me go back to my code. So let me type in. It expects me to type in, otherwise it's throwing me out. So what is the key that is going to be for your K1 and V1 is going to be long writable. The value is going to be text. The output is going to be text and int writable. Okay. So let me go back to the documentation. Just give me 1 sec. Let me go down to the same slide, the word count example. Okay, there we go. So K1 and V1 is your long writable and text, right? Because long writable is offset point and text. And what is going to be the output of the mapper? K2 and V2, that is going to be a text and a number, right? So that is what is this value over here, text and int writable. In the mapper class, you will have to override a function called as map. Map will take in its parameters the same key value pair and a context, which is going to be responsible for spitting out the output of the mapper into the local node wherever the mapper is executing. Throws, IO exception, interrupted exception are the Java related thing for exception handling. Then what do I take? I take the value dot toString, which is converting the value which is a text to a string. Because what is text? Text is like a Java code, a Java wrapper for the Hadoop type. So text in your Hadoop is similar to your string in your Java. So I take up that particular value and I use my string tokenizer. That's a class which will allow me to separate words in a line based on a space. Then I put it into a loop so that I will keep on looping through the data, and then I check if it has got more tokens. That means if there is something more in the string tokenizer, I get that value and I put it into the value over here, whatever is the value that I wrote. Okay. So, and then I am going to say my context.write of my value and int writable. So this is what is the word, and you are suffixing to it a 1 to it. Just give me 1 sec, friends. I think I have not copied one of the lines that was there on the top. Okay, they're using the same value. That's okay. That's cool. So this is what is, sorry, I minimized it by mistake. So this is what is the code that we have in our mapper. So we are finished with this code, guys. And in Eclipse, you can right click over here on wherever the highlighted area is there, and then you can say show line number, so that it will be easy for me to specify with the help of a line number. So my mapper is finished. Okay. So while it's finished, so now I'm just going to write over here end of mapper, because that's me. I would like to have it commented. Now let me go down to my reducer. Let me scroll down. This is what is my reducer code, Control C, and I'm going to put it over here. So now let's look at this. So first thing what you see over here, reducer, it gives me an error. So you know that you have to take your mouse on top of that, and you'll have to say that you'll have to import your reducer, apache.hadoop.mapreduce reducer. Okay, so it should import that, and that will take care of it. So all of my problems are solved over here. Control S would solve it. Now what do? In our reducing code, similarly there is a text and a int writable. That's correct, because the output of a mapper is a text and a int writable, and the final output will also be text and int writable. So the key value would be the same for the reducer. Then I say there is a function called as reduce. The key is the text. The value is iterable. That's a collection, because remember what is the value over here? The input to the reducer is a key and a list of values, right? The list is what is represented by iterable over here. Okay, and then you have got a context. And then what do? I generate keep a variable called as sum. I'll simply loop through all the values that you have in your code, okay, for int writable values, and then I simply say sum plus equal to. So you can see over here the way how I will convert that into keep on adding up the values for the same key. The framework will guarantee that all the values for the same key will come together, so I don't have to use my key for doing any business logic. I'll simply keep on adding it, and what is going to come out of the reduce? The key, that is nothing but the word and a sum of all the keys, that is aggregation, whatever you have done. Okay, so that's what is the concept over here. So now our logic for our mapper and the reducer is finished. Let me write my comment over here, end of reducer. Okay, now comes my driver code. So now let's move on. Let me go down to the word count and let me pick up the last part of the code. Public static void main. Control C, and after the reducer, Control V. So let's look at what this particular code is doing. This covers up our logic for our code. So we are starting from public static void main. I'll take my mouse on top of the other code so that you would know that I have to start with importing. So configuration is there in Hadoop, org.apache.hadoop.conf, the third one. Then job is also there in your second one. MapReduce package is what you have to use. Okay, the name of my class is not word count, right? It is WC example. So that's why you get this error. Let me say WC example. Then I have to, sorry, my example. I can't spell example, silly. Now go to your text input format. Let me load it. This will be there in your MapReduce, and text output format is also going to be your MapReduce. Please remember, if you get MapRed and MapReduce, you will have to select MapReduce. Okay, friends? Because there are two things that is there, so you will have to select MapReduce, please. Then path is going to be again there in org.apache.hadoop. First of all, select Hadoop, and in Hadoop you will have to, if you get MapRed and MapReduce, use that. So file input format, you see there is something in MapRed and MapReduce. Always use MapReduce because MapRed is an old API. So for Java guys, on page number 27 of the Hadoop definitive guide, it is there. Okay, the differences between the old and the new API. Cool. So let's understand what we are doing over here. First part, what we're doing here is In case if you're using the, hey, before I start, let me have a look at the questions window. If there are any questions I can answer. So Velan said, hey, that's fine, Velan. You can ask me any question. That's all okay. So to be a good developer, you should be aware of which imports are required. Hey, see, import can be done. Say, ideally, if you're talking about a developer, yes, you should know from which class or which package you're going to use the class. Yes, you should know that. Because otherwise, not only for being a good developer, for any normal code also, you should know the right package. Okay? Velan said, context is the one that maps the key with the number of occurrences. No, context is for writing. You say context.write, right? Context is for writing. The mapper context is for writing into the node, and the reducer context is for writing out of your reducer node. So now you have got a configuration. So I created a configuration class. Then I created a job class and I passed my configuration, and this is what is the text of that particular configuration. So you will get a warning. If you look at this warning, it says the constructor for the configuration is deprecated. That means there's a new constructor what they're looking at, they're suggesting, but then that's okay. We can go ahead with this deprecated because this is the appropriate way how it will work. So configuration will look at all your XML files. Okay, so if I were you, I would go down to my documentation and try to look at what all are these configurations. So let's go down to the third package that is on the top, that is hadoop.conf. I will look at the configuration and then it will explain to me configurations are specified by resources. Okay, so unless turned off, it will look at two resources. Okay, default.xml and site.xml. Okay, so you will have to look at each and every class that you see over here in the documentation. Fine? Cool. So you create a job class and then you do the three things that is necessary. Set what is the driver code. Driver code is a code that will be executed. That is my code. That is my WC example code is the driver code. Who's a mapper and who's a reducer? If you are using your earlier API, that is your jobconf API, you would be saying something like conf.setMapper. You would specify conf.setName. We've just kept it over here so that you know the way how you could do it in the old API. But then that is not important, but then you should know the way how it could be executed. Okay? Then you specify what is your output of your reducer. It is mandatory. This is the code that talks about the splitting logic. So job.set input format class. Remember I told you about input format? Input format is a class which will take care of the actual splitting logic. So let me go back and show that to you right now over here. So in the documentation, if you go down to org.apache.hadoop.MapReduce, and if you look at your input format class, and if you see over here, this is what is important. So the MapReduce framework relies on the input format of the job to one, validate the input specifications of the job. 2, split up the input files into logical input splits, each of which is then assigned to an individual mapper. Got it, guys? So if you want to know, remember I said /n is a default input split. Look at your file input format over here on the top. And if you click on the text input format, you will see over here, this is an input format for the text files. And what does it say? Files are broken into lines. Each line, feed or carriage return are used to signify the end of the line. Keys are the position in the file, that is offset point, and values are the lines of the text. If you don't say anything, the default is going to be a text input format, and I'm specifying what is the output format. Okay? So line number 69 and 70 is saying what is my input format. Then I create a path. A path is a location for configuring to a path in the file system for the job. Okay, then what do? I would say file input format, and I'm adding. So that means when I'm running my code, the whatever is the first argument that I'm passing, that is what is going to be the location of my input file. Then I say my file output format dot set output path of an args1. This is the folder that will be storing the results. So if you want to automatically delete the output file when you run this program again, I'm showing you programmatically how to do it. So output path dot get file system conf dot delete output path. Okay, that is only for letting you know that once if you're running the program again, hey, this is dangerous. Just give me one sec. So what does this do is, if the folder was already there, it will delete that folder for you. In a real world, you should not do it like this. But then for a class purpose, it is good because I will run this program again and again, right? So what would happen is, if the folder is already there, it will simply delete that folder for you. Okay? So what does line number 79 do is, it will delete the folder from your actual file system, okay, before running it again. So then wait for completion is the way how you will submit your job. Okay, and what the system.exit means, I will wait till the time my job is finished. This is what is the whole driver code for. Okay, so this is how the code is written, friends. And now you need a jar file out of it. Okay, so you will right click on the word count project on your project explorer, and there's an option called as export. I would say export. What do you want it export it as? You want to export it as a jar file. I would say next. Where do you want it to be exported? Let me click on browse. Okay, and let me put it to the home Edureka folder. Okay, and the name I'm going to keep it as wc.jar. Okay, so what am I doing? I've written the code, it's already compiled. Then wc.jar, it is going to be written in home Edureka wc.jar, and I'm just going to say finish. So it will automatically create the jar file for you. It's saying, do you want to save it? Of course I want to save it. And okay, I'll say okay. The reason it is giving some error warning is because of these things. See here, these are some of the deprecated APIs, right? So the constructor is deprecated. So we are still using it. See over here, it's not, when you see a red one, that's an error. When you see a yellow one, that's a warning. My jar file is ready. So we are finished with this. We have got the jar file ready. So now let me go ahead and have a look at this. Hey, and by the way, my data file is over here. It's there in my LMS, in my desktop. So I need to know the path of it. If I go to the properties of it, because I need to put this file into HDFS, right? It's in home, Edureka, desktop, LMS, man, it's a big one. Doesn't matter. We will have a look at it. So this is what is my data set. I want to do a word count on this big data set. Okay, friends, that's what I'm going to show it to you. So let me open up my terminal window. Let me do a ls over here. And see, I've got my jar file over here, word count.jar. Okay, that's ready. Now if I say Hadoop fs space, dfs space minus ls space slash, just to see if the data is already available or not. Okay, so in HDFS, of course my data is not there in HDFS, I know. So there is a folder called as Terragen output. That's what we created last time. There is no folder, there is no file of ours. So what do I need is, I need to go down to the folder where I have got my data. So where is my data? It's in my desktop. So I would say cd desktop, cd LMS, cd MapReduce. And where is my data set, friend? My data set is there in this one. Okay, so I'm going to say cd, just give me one sec. I don't know why people create such big names. Oops. right click, copy, right click, paste. Okay, come on, crap. What's happening? It should work. Let me do a ls. Just one sec. cd module assignment 3. Okay. Yep. Because there were spaces in between data set. That's the reason it didn't work. But then here we are. I went it only till dash, right, friends? So computer doesn't understand that it is that I'm asking to go to word count. So there's word and word size also. So I'm there in the right folder now. So if I do a PWD, it'll show me where am I in. Now if I do a ls, this is the data that I have. I want to put it to HDFS. So guys, I forgot. Can you please help me? How do I put something into HDFS, guys? How do I put some data into HDFS? Put or minus copy from local, right? So I can use both put or minus copy from local. So let me go ahead and just one sec. I like to keep it maximized so that it would be easy for us. Let me do a clear. Okay, so I'm going to say Hadoop FS. Sorry, it should be HDFS. HDFS FS space minus put space. I forgot what is the name of the file. Let me do a ls word count problem. So HDFS space FS space minus put space word count problem, and I want to put it in the root. Okay. There we go. Hey, could not find. Sorry, it should be, I think it's DFS. I get mad with this way when they change it. Okay. So there we go. Hadoop DFS minus put wordcon problem slash. You see how it is moving that file into HDFS at the root location. Okay. Good. Now, if I go back to my browser and see, I should see that file over there. Let me go down to my browser. So I'll click on this Hadoop name node status over here. I'll click on browse the file system and it should show me the file. There it is. Small file, 47.69 KB. Okay, the file is already there. And now I want to go ahead and run my example. So I'll say cd enter so that I go down to my root. Where is my jar file? My wc.jar is at the root. Let's run this program. Okay, good. So now I will say Hadoop jar. What is the name of the jar file? wc.jar. What is the name of the application? in.edureka.wc example. So in.edureka.wc example. WC example space. What is the location where my data set is? Man, it's such a big name. Word count problem. Okay, I would say slash word count problem space. What is the folder where I want it? Let's call it as WC output, word count output, and I press enter, and here goes your first MapReduce job. So it is saying that unable to load some files. That's okay. See how it is connecting to the resource manager. Okay. Yep. So it's saying some of the classes are deprecated. That's all okay. Don't worry. Let it run. See, it says submitting tokens for the job. It's giving a URL. This is what is the job ID that we would be seeing. Okay, where the traditional systems will fail and this would excel beautifully. Okay, the map is finished. Map 100%, reduce 0%. The reducer has to finish. Once it's finished, it will put it into the output folder. Okay, there you see the reducer has finished, and you will see how it will give you the details. The file system counter has got 43 counters. There is a file counter. There is HDFS counters. What are the job counters? And look over here. The map input record, there were 103 lines. There were 7,352 words. The combined input records, the unique words were 351. And you will see 351 words with the count of it. Okay, and it will give you the value. Got it, guys? This is the way how it would work. So where would the output be? The output would be there in the browser. So let me click on Go again. I see the WC output folder. Let me click on the WC output folder. You would see that there is a part file. And if I look at the part file, you would see all the words that is there. Okay, and with the explanation and the number of counts. So he has got big 51 times, of course, big data. Okay, big in capital and big in small. That is the most number of common occurrences of it. Okay, so I don't see anything more than that. So you can scroll down and you can, hey, data is 118 times. Okay, small data and capital data. Got it, guys? So this is how you run a typical MapReduce example. This was the demo that I wanted to show you.